What's up, bros and hoes? I can't zoom in anymore. Okay, there you go. You guys want to see her? There you go. Anyways, today I'm going to show you guys working on the 47 S11 Desoto, made by Chrysler. Which also made Dodge, Plymouth, Chrysler, and Desoto. And I'm going to show you guys what a slow starter looks like. I've got myself here an old battery charger. It's got 6 volts and 12 volts, pretty good. It says their battery condition controls charging rate, so it's at pretty much 0. So essentially the battery should be good. And the battery is new. I've got 2 batteries actually connected in parallel. Actually, the other one's disconnected now, so I just have one. But I had jumper cables, the positive to positive, negative to negative, basic electrics. It's a parallel connection. Voltage stays the same, and current adds. If I were to attach the positive here to the negative there, then you'd be left with a positive and a negative terminal, and then use that as a big battery. Then it would be like a 12 volt, and current would be the same in series, right? But anyways, I'm just gonna set the camera down here and just watch the fan blade. It might actually start because the battery is really charged up now, but it's pretty slow. Setting the camera here on top of the battery, so yeah, I mean, you can see it there, right? There's the fan blade there. You should be able to see it there. Let's hope this camera doesn't fall off. Let's go ahead and oh, sorry guys, it's sorry, my bad. It's not moving because I removed the generator. It's all loose up now. But anyways, as you can hear, that starter is really slow. My bad. I had done a previous video here, but I got deleted by accident. But anyways, this is turning like really slow. I mean, so slow that if you put your hand here, it wouldn't hurt it at all. It's like literally, you can see the blades turning. You know what I mean? But what I'd like to, just before I go into some other details, I'd like to show you guys my testing procedure for these cars. When you get these cars that they've been, neglected for so long, there often is more than one thing that needs adjustment. I mean, most of the times, especially if you watch those shows with roadkill, that's a pretty cool show. But what happens is, most of the time, all you need to do is, you just put some gas in it, and you're usually good to go, but this car, I want, that's good for, short periods of time. Whereas, in terms of a, long term, there's like old wires that have been rotten, there's the inside. You need to do a tune-up of the engine, tighten the engine head, things like that. But most of the times, you just want to move the car to get it to where you want. It's pretty much just what the roadkill guys did. A couple of days or or even a few hours, and you got the car up and running. But for here, as I was saying, in long term, in the long run, you do have to, you will have to change and check certain parts. And the easiest way that I find is just to remove everything that's not part of the the circuit, the system that you're working on, right? And so in this case, I have removed the generator, and the voltage regulator, okay? Because the only thing that those two things do is the generator charges the battery, and the voltage regulator, it does just that. It's actually a current regulator as well, voltage and current regulator. It just controls the output of the generator so that it's not overcharging the battery and the lights, right? Because the faster the generator spins, the more electricity it produces. So it could actually produce something like over 60 volts, and the car is only 6 volts. In this case, it's 1947. Probably switched to 12 volts in 1950s, maybe even, late 1950s. Sorry, but so that's what I like to do, and that's what I did in this case. Just before we go into the actual slow starting, the other things I'd like to mention that some of the old 6-volt cars, they had a lot. I hear a lot of people saying that, because of that, as I was saying, the generator turns faster, produces more electricity. They used to. I've seen a lot of people saying that at a stoplight, or when the car is stopped and just idling, or even if it's idling for a long time, it could actually die because of insufficient charge of the battery. Or the lights would go dim, right? The only reasonable explanation for that is if the voltage regulator is not working properly. Now, even so, if that isn't the case, what I have here, when I put on this car, is I put an upgraded, a larger generator. Probably was for a bigger car, a bus or something. But it's a Chrysler generator from the 40s as well. And guys, it just fit in there just perfectly. I didn't actually know I bought it off of eBay, but that was, I don't know if I could say lucky, but back then they used to make most of the parts the same, right? So I'm just going to quickly show it to you guys here. The generator is just the same as an alternator. The only difference is that from the generator, it's actually simpler, and the output is already direct current. That's what the battery is. The battery is direct current. Now the alternator, it alternates, so it's an alternating current, right? So it needs rectifiers and diodes to convert that alternating current to direct current, okay? So that's what it is there. I'll show you guys here. That's the, let me get out of the way here. Fuck. There it is there. It's bigger and sturdier than the one that came with the car. There it is. Never mind. I'll do that in another video. So it's a lot simpler to deal with the generators. I know a lot of people give them shit because, they need to upgrade to an alternator, but these things, you see, they work just fine. I think I have one of these brushes the wrong way. Alright, anyways. But as you can see, back to the slow starting. As you guys heard, it's, painfully moving, moving really slowly, whining and grinding. Now, one thing that I need to mention is one possible cause for that is the handbrake. Right, there's the handbrake there. But the handbrake on the this car, the Desoto, it actually goes around the output shaft, and so if it's stuck there, which it, you know, it is in a lot of cases, you know, then it's actually, you know, forcing the motor. And so the difference between the handbrake in this car and then the Rambler American there, for example, is the handbrake, it actually on the Rambler American there, it actually, you know, pulls the brake on the wheels themselves, whereas here the brake is on the main shaft. Right, so it actually locks the engine, whereas the other one locks the car. And there it is. See? There's the output shaft, and there's the spline. They put a spline in the middle of the shaft so that it's adjustable. I really, really love this. So you see that round part, and that cable there, that thick, you know, steel cable there. That's for the handbrake. And now, you know, now it's clean because I cleaned it up. But when I got it, you know, it was stuck there. So, you know, just before you start working on the engine and all sorts of shit, just check that. Okay, and I think most of the cars from the 40s are like that. After that, they switched to the brakes on the handbrake on the actual wheels. This handbrake is just as good, but I mean, I guess it's the ones on the wheels are better. But anyway, so now that you've checked that, hopefully you heard something else. You heard like a click, and like I said, you know, everything is removed there. It's just from the voltage regulator is there. There it is, right there. One more thing. Hang on. You see here, I've got big, thick construction wires. So it's really, literally, really thick. You see, it's as thick as my thumb. It's like 10 millimeters thick or something like that. And the other one too. And what I did on the other one is, you know, you'll probably see it later on. I welded a nut at the end of it so that I could connect it there. You know, they have like crimping, you know, connectors that crimp around the wire, but they're not only really expensive, but the actual tool for the crimping tool, it's literally hundreds of bucks, hundreds of dollars. So, you know, simple way is just, you know, weld a washer or a nut to it. It's got to be a washer, a nut in this case, because it's really, really thick. You'll never have a wiring problem in this car, and you'll always have maximum current. If you put a wire that's too thin here, you won't get enough current. So that's not a possible cause here. And yes, you can weld copper to steel. It's really easy. There's no tricks. It's actually easier than I actually even say that it's easier than steel to steel, because the copper, it doesn't oxidize. So you actually create sort of like a brass, sort of a bronze compound, you know, really strong, really good. But anyways, there it is. If you don't have a welder, you could just buy one of these connectors. But anyways, now that I've covered that, and by the way, the solenoid on this starter here, I know a lot of starters from the 40s, you'd have either a push button switch, or you'd have a foot pedal. You know, you'd press the foot pedal and it would push the starter motor into the engine, right? You do that mechanically, and I really love that because, well, as I always say, mechanical is always stronger, more reliable. You know, it's better in all aspects than an electrical system, okay? Electrical is always inferior. No, it might be cheaper, it might be easier to install, but electrical is always more less reliable. Okay, mechanical, you know, you got big thick pieces of steel, you know, on the it's not going to break, you know. And I mean, if it breaks, you could just put something in there, make it happen, you know. Whereas if it's electrical, it's a lot more of a pain in the ass, you know. But in this car, I don't know if the starter is original. I mean, it is an original starter from the 40s, but you know, there is a push button hole. There was a push button on the dash, so perhaps they switched it back then, right? Or maybe it was optional, I don't know. But the solenoid there, it's got 4 terminals on it. On the bottom right, if you're looking at the terminals, you've got the thick, you know, cable here, thick wire coming from the battery terminal. Then on the other big thick terminal, you'll see that it's got a steel, you know, it's got a steel tab that connects to the motor. So that's where the motor turns, right? It just turns on the motor. So if I actually get a chisel and connect those two, it's just going to turn the motor. It's not going to turn the engine because you need the solenoid or something, you know, either a foot or whatever to push that shaft in. And the shaft is actually open. It's an open end, it's not closed. So you could actually put like a, for whatever reason the solenoid is not good, you could just put a, you know, like a pry bar or something in there. But it is a bit of a pain in the ass too. There you go. Let me see. Zoom in. See there? So you got to push that in, that solenoid, that plunger, so that it pushes the motor into mesh with the engine, right? So there's 4 terminals there. And the top ones, one is from the ignition switch, and the other one goes to the normally cars would only have 3 terminals. This one is special because it has 4, and it is a really rare, you know, I've looked around it, a lot of people say that it is pretty rare. Okay, but what they did is, it's really interesting. Instead of just going directly to ground, they actually put that wire from the top left corner, and it actually goes to the generator, right? And it passes through the field coils of the generator. Right now I bypassed that, and I just connected to the zoom in, you motherfucking piece of shit. It's actually connected there to the ground terminal, the positive terminal in this case, of the car. But why they did that is, the reason they did that is, since it's going through the coils of the generator, right? It's actually attached to this terminal here. Okay. So the reason they did that is, if the coils inside here are damaged, then the car won't start. So basically, you know, if the generator is not charging, it's not working, then the car won't start at all, right? And that is really good because, you know, even today, you can start a car, you know, and it's, you know, you can start it, you can drive it for a few minutes, even if the alternator is bad. So way back then, they have technology that's not even, you know, they don't even have today, right? It doesn't allow you to start if the charging system is not working. Because let's say you do start the car, then you start driving, and then you're stuck in the road, right? And then you got to pay somebody to tow you. Whereas this way, the way that they have here, your car won't start anyways. So, you know, it's just unbelievable, guys. And it's just really simple. You don't need all those fucking wires, all those fucking whatever, you know, thousands of relays, thousands of switches, thousands of sensors. Just really simple. Through the field coils here, then to the ground. Instead of going through the ground directly, it goes through here, then to ground, right, to the case. So if the coils here, if there's a break in them, then this won't work, and it won't allow the car to start without this working. So it's just really amazing. So that's what the extra terminal is for. if you just want to test it, you could just remove this terminal from the fourth terminal, the one on the top left, and just connect it to any place on the body of the car. But I might show you later on this. But anyways, now I'll show you here what the problem probably is, right? Actually, I'll see if I'm able to turn the motor of the starter. It actually turns pretty quickly, and I'll just see if I can show you guys. I'm just gonna bypass it, just like in the movies. You just get a chisel, just anything that's steel and conductive, like a screwdriver. Shut the fuck up, assholes. And I'm going to connect the two terminals so that I spin just the motor. It's not going to crank the engine, it's just going to spin the motor. There we go. Don't put it on the thread, because it'll spark the thread, and it's gonna, you're gonna have a little spark, but that's normal. Come on. Damn it. Hang on. I'm trying to get, it's just a pain in the ass here. And I've got the car pretty high. Okay, if I can hold her steady right there. That. So, you see the engine is not cranking, it's just the starter that's turning. You gotta push the starter, the solenoid, that part there. It's a lever here. So you push this in, and that part there pushes the plunger inside. Into the flywheel gear. Alright, so it's those two things. So if your motor's just turning, then if just the motor's turning, then you've got a bad solenoid. And the reverse, and the contrary, if the solenoid is just clicking and the starter's not turning, then you've got a bad motor and a good solenoid. I mean, obviously you can have the wires, right? Bad wires or wrong connections, but assuming all that is good, and that's what I have here. So since the motor is turning pretty fast, I'm thinking that the solenoid is the problem. Now it is working. That's the thing. This is the worst situation, because it is working, but it's not working properly. If it's just completely dead, one or the other, then it's a lot easier to identify these problems. But since it's just, it's half working sort of thing, it is cranking the engine, both the solenoid and the motor, they are moving, they are turning, but they're turning, there's a problem there. Since the motor seems to turn pretty quick, pretty fast, I'm thinking that it's the solenoid. But what would cause the solenoid to cause the motor to turn slowly? Now, this is what really baffled me, but in the manual of the car, it says that there's actually two coils inside that solenoid. So one is a big coil, and it actually uses up 85 amps, and the other one is a smaller one, which is 12.5 amps. So one of them uses a lot of energy, a lot of electricity, whereas the other one uses less. But the idea is, that thing, the spring on that thing, it is really strong. I can't push it by hand because there's not space there. But Even if you're trying to push it by hand, it is, you need to have a good arm for that. A lot of jerking off. But you need to have a really strong hand for that. For pushing this starter. So, electrically, you need a lot of electricity for that. So the idea is, what they have is they have a big coil that'll, push that in, and then once it's in, the smaller coil will just hold it in place. It's easier to hold something in place, whereas as opposed to moving it. Okay, it's easier to hold something stationary rather than move it. So the idea is that big coil, it will turn off. Now that's the only thing that I'm thinking that is damaged here. One of the coils, right? And what will happen is here, the battery will get discharged really quickly. So I'm really thinking that it's that. I mean, if it's using up 85 amps, that 85 amps of the big coil is just supposed to be really quick, split second, just to push the starter into the flywheel, right? But if that is wrong, if that's a problem, there's a short somewhere, that electricity is, leaking, basically, right? So electricity flows just like water, right? It's a flow of electrons, basically. Don't ask me a lot more about that, but that's how it works, just like water. So, if you have a big leak on the water somewhere, then, the water's not getting to where it's supposed to be. So, the starter motor itself, it's turning fine, apparently. But there's also tests for that, because it can turn slowly too, right? So I'm not 100% sure. But now the thing is, I'm going to show you guys here why I'm pretty certain that it's a solenoid. One of the coils, I'll show you in just a second, but at this point, I just buy a new starter. But in this case, starters from the 60s, even other cars, they're fairly easy to find, fairly cheap too. Starter for the cars from the 40s, they are kind of rare, guys, because it was, they're post-war cars, right? The car makers, there wasn't a lot of cars around because they had been making, bombs, tanks, guns, and all sorts of, war equipment, and, people didn't really have money. So that's cars from the 40s, they are more rare, okay? So, that's another thing. If you're going to buy a classic car, I'd really recommend buying, a popular car. Now, it also depends, like the Ford Model A, it was mass produced by Ford, right? So everybody knows that car. So it is really simple too. So that's a really good car to have. But just look around, right? And in the case of this starter, you can put another starter, right? I know this is the Model S11. I know that the Model S8, it didn't have the solenoid because it used a pedal, right? You just have like another pedal, just like the clutch, just like something else. You'd have a pedal and would push the starter in. So, like I said, it's mechanical. It's a lot simpler, a lot stronger, a lot more reliable. So definitely, I want to replace or modify this starter. What I can do to this starter is the way it is right now. I can, I'm going to remove it, and I might just add a lever to where the instead of that solenoid, I'll add a lever and I'll make a push pedal, and then I'll add a starter button to start it, or you can just use the key as the way it is right now. The way it is right now, it's just like a modern car. You just turn the key. Right, back then, not back then, right? The other models, you'd have to push the pedal in, then turn the starter switch on. Just a tiny bit more work. I don't know why. Is it so fucking hard to push a pedal? Why do you need to put a switch? But anyways, this car was for the rich people. You know, they wanted these little, you know,